Hey everyone, welcome to the Polynomial Functions Test Review. This one's labeled Day 2 if you're one of my students because we did something a couple days ago. So I'm going to do the odds and you do the evens, okay? So number 1 has this whole function here and it is out of order. So I do ask if the degree is odd or even and for the degree number. The degree is the highest power, so the degree is 4. Alright, so the degree number is 4. 4 is an even number, and so that takes care of the first two. Alright, the next thing is the leading coefficient. What's the number and is it positive or negative? That's this right here, negative 1.3. Whatever's in front, the big number in front of your degree term is your leading coefficient. So I'm going to write negative, and then I'll write the number itself right here, negative 1.3. The next thing to talk about is the end behavior. The end behavior is, which way is the graph going to go on the left and the right? Is it going up and up on the left or down on the left, up on the right, down on the right, that kind of thing. So in my other videos I told you that the x's are always going to go negative infinity to positive infinity because we read these from left to right. So negative infinity represents the left, positive infinity represents the right. The f of x ones are the up or down ones. And so if it's even, they're either both going to go up or both going to go down. Up for positive, down for negative. And we have a negative function. So in these y ones, or the f of x ones, I'm going to write negative infinity both times. Okay, so that takes care of the end behavior of that graph. Alright, to evaluate for x equals negative 3, I am just going to do Control T. And that's just, plug this whole function in. And let me point to it. There we go. This whole function, plug that in, press Control T. And on my calculator, I get negative 134.3. Alright? And then I do ask you to put it in standard form for the last blank here. So the last blank, put in standard form, let's just rearrange it. You want your powers to go in descending order. So I'm going to put this first, then I'll put this second, this will come third, and then this will come fourth. Alright, so it'll say f of x equals negative 1.3 x to the fourth, and then what was it? Something like 2x, minus 3x squared plus 2x. Minus 3x squared plus 2x, and then it ended with plus 4 if I remember correctly. And so that's all it takes for the put it in standard form. It's just rearrange it. Alright, yeah. So you do number 2, I'll move on to number 3. Here's our function here, or our graph I should say. Is the degree odd or even? They are both going up. So if they're going in the same direction, it's even. If they go in opposite directions, it's odd. If they're both going up, then it's positive. And so the end behavior of that graph would be plus infinity for the y's. For both y's are both plus infinity. And then, what else did I want to say? Oh yeah, the x's. Lost my train of thought for a moment there. The x's always go negative positive. So, yeah, that takes care of the end behavior on number 3. And so number 3 is done. Yeah. Number 4, f is increasing on the intervals. So let's see here. Reading this from left to right, it goes down, then up a little bit, then down a little bit, then up again. So the first increasing interval is right here. So we just need to know their x values. So negative 4, and then this has to be at negative 3. Alright, so it's just increasing between negative 4 and negative 3. So I'm going to write -4, comma, -3. And then I'm going to look at the x values of the next increasing one. So -2, and then it's going up and to the right. You know, you just read these from left to right. So it doesn't matter if it's going up. It just matters if it's going to the right or left, and it's going to the right. So it's going from -2 to positive infinity. Because that's going to the right. So -2 to positive infinity. And that is the increasing intervals. Now, the decreasing intervals, it's coming from the left. It's easy to make the mistake of saying, oh, it's coming from positive infinity. But remember, the thing I'm trying to stress the most here is it coming from left or right? Okay, just look at the x value. So it's coming from the left, and then it turns at -4. So I'm going to say negative infinity to -4. And then it increases here and then decreases there between -3 and -2. And so that's all I write for my second answer. Alright, and then where is it greater than 0 and where is it less than 0? It is not less than 0 anywhere. If you look at it, it touches 0 twice. But it does never, it never goes below 0. So I'm just going to put an NA there. And then we'll just focus on writing the greater than 0 answer. So when it's greater than 0, it's everywhere where it's not touching the 0, because it doesn't say greater than or equal to, it just says greater than. So what I'm going to do is I'm going to write negative infinity to -4, because that's the first time it touches. And then from -4 to -2, because then it's above it right there. And then once it hits -2, it hits 0. So this one's actually kind of a tricky answer if you think about it long enough. But then from -2 to positive infinity, it hits 0. Or I mean, above 0, sorry. So yeah, that's the greater than 0 one. The domain and range, in the 5.8 notes, I said that the domain, whether it's odd or even, is always all real numbers. And then if it's an even one, it just depends on the highest or the lowest y value. And then if it's odd, the range is all real numbers as well. So the domain, all real numbers, and then that range depends on that highest or lowest value. So the lowest y value it ever touched was a 0. Alright, so, and then it went above that. So y is greater than or equal to 0. So that's all I was looking for on the domain and range on that one. So this one's odd. So domain and range, all real numbers. It goes up and down freely, left and right freely. 6 and 7 we're doing in the calculator. And then I'm just kind of putting it all together here. So I'm asking a bunch of questions on 6 and 7. The first thing I ask are the transformations. So what is this negative doing on the outside? That's any negative on the outside is an x-axis reflection. The next thing to identify is what that 9/8 is doing. If it's bigger than 1, it's a vertical stretch. If it's smaller than 1, it's a vertical compression. 9 is bigger than 8. So if the number on top is bigger than the number on bottom, it's bigger than 1. So it's a vertical stretch. When you add on the inside, you know it's on the inside because it's in parentheses, it goes left. Minusing would go right. So this goes left 2. And then if you add or subtract on the outside, it's going to go up or down like normal. So this is just down 5. Remember that inside stuff is opposite of what you would expect. So yeah. Then we're going to graph this, and we're going to find the local max and min and zeros. So I can't show you the graph while doing this video. So you're going to need to make sure you do that yourself. And then I'm just gonna graph it off screen here. So I'm gonna graph this, or I graphed it, excuse me, on Desmos, and it's kind of funny because most of the time when I do these to the fourth power ones, they make like a W or an M, but sometimes they just make kind of a U, and that's what this one does. So some of our answers are very simple. So the local max is that -2, -5. That's technically I guess the vertex. But then there's no local min because it doesn't curve. It doesn't curve like this, where this one has a local max and a local min. You see what I mean? So the zeros, there are no zeros either because this one went below the x-axis, and so f of x is greater than 0, that doesn't happen either. And then less than 0, that would be all real numbers, because everywhere, every number that you plug into that function would get you a number less than 0. So yeah. So kind of funny how that worked out. So the domain is all real numbers, because I said that in just the other one. It's all real numbers always. And then the range just deals with that highest or lowest value. So you look at the y, because range deals with the y. So -5 here. So I'm going to say, and it's going down, right? So I'm going to use the less than. You have to use less than or equal to, though. So less than or equal to -5. So that takes care of the domain and range. Last thing to end this with is the decreasing and increasing intervals. Basically, it comes up, and then it turns at that vertex, and then it goes back down, right? So it is increasing from -infinity, since it's coming from the left, to, and then you just look at the x-coordinate, right? -2. And then from -2 to the right, it doesn't matter that it's going down, it's going down and to the right. Remember I said it, you look at this from left to right. It is decreasing, so -2 to +infinity. So yeah, kind of a weird example, but I think it's good enough for the review. Hopefully this one is better for you to do. But other than that, thank you for watching, and good luck on your test. Goodbye.